Imagine a meticulously painted miniature horse slipping from your hands. It hits the floor, shattering into pieces and exposing a crumbling, chalky interior. In model horse collecting, a piece's physical survival and financial value are tied directly to its underlying casting chemistry. The problem is that the art market has commodified the word resin. It has become a generic, deceptive catch-all term that hides what you are actually buying. A museum-quality miniature and a cheap tourist souvenir sitting on a gift shop shelf might both claim to be made of resin, even though their structural integrity and lifespans are completely different. Relying on that single generic word obscures a critical chemical trade-off. The specific polymer used dictates whether a collection will survive for generations or degrade and crack within a few years. Behind the scenes of the casting market, materials divide into two distinct competing chemical systems. Those two paths are polyurethane polymers and polyester composites. The generic label resin at the top splits into two entirely different manufacturing approaches, polyurethane polymers and polyester composites. This chemical split determines the final piece's physical properties, controlling everything from the crispness of a sculpted muscle to the model's structural stability over decades. Recognizing this structural fork in the road provides the chemical context needed to identify the difference between a fine art casting and a mass-produced imitation. Let's start with unsaturated polyester polymers. When applied to a miniature scale, this material presents a severe structural flaw. This dynamic comparison shows the issue of volumetric shrinkage. Volumetric shrinkage is the amount of physical mass a material loses as it transitions from a liquid to a solid. The cube representing polyester shrinks by 4 to 10% during cure, while the polyurethane tube next to it shrinks less than 1%. As the polyester contracts so dramatically, it pulls away from the mold. This extreme shrinkage rate destroys the microscopic surface textures that define fine miniature sculpture. On top of that volume loss, the base polyester network lacks chemical toughness. The final cured structure is highly brittle and prone to cracking under the stress of its own shrinkage. To compensate for this high shrinkage and extreme brittleness, manufacturers rely on a specific chemical workaround: heavy filler loading. They pack the liquid polymer with solid bulking agents, like marble dust, fine stone powder, talc, and wood flour, to stabilize the cure. The industry term for a polyester composite heavily loaded with these specific bulking agents is charged polyester. Charged polyester is highly cost-effective if you are casting large, faux stone garden statuary or architectural pieces, but its heavy, brittle nature completely erases the precision required to produce fine art miniatures. That brings us to the exact material that built the model horse hobby from the 1980s onward: polyurethane. This material profile matrix directly compares our two options. Looking at the first row, the shrinkage rate for a polyester composite sits between 4 and 10%, compared to less than 1% for polyurethane. The underlying chemistry explains this difference. Polyurethane forms a highly controlled cross-link density during its cure. Cross-link density refers to the number of chemical bonds connecting the polymer chains, which dictates how rigid and stable the final structure will be. Because this highly cross-linked cure is inherently stable, polyurethane requires no heavy bulking fillers. It produces a strong material without the brittleness found in polyester. The total lack of bulky powders and stone dust allows the pure polymer to capture the exact original sculpt with extreme fidelity. The pure liquid polymer flows seamlessly into the microscopic, highly detailed crevices of a silicone mold, without any granular fillers blocking the way. Polyurethane is the model horse standard, specifically because artists required a high-performance material capable of locking in microscopic detail without warping or aging poorly over time. There is a major caveat to this standard. The name polyurethane covers a massive global chemical category, and the vast majority of it is completely unsuited for art. Most standard foreign-manufactured polyurethane systems are formulated for industrial construction, automotive parts, and bulk-molded plastics. When applied to fine miniature sculpture, these industrial formulas fail. They suffer from unpredictable viscosity, extreme moisture sensitivity during cure, and poor pigment stability. To bypass those failures, the model horse hobby relies specifically on American manufacturers like Smooth-On, Polytech, and Aluminolite. These specialized U.S. companies engineer specific small batch formulas that are purpose-built for ultra-low viscosity and incredibly sharp detail capture. Demanding U.S. art-grade resin ensures you access purpose-built chemistry that guarantees long-term finish predictability rather than gambling on bulk industrial plastics. To make an informed decision as a buyer or caster, we need to synthesize the distinct trade-offs between these three specific chemical paths. This quadrant chart plots effort and cost on the x-axis against longevity and detail on the y-axis. In the bottom left, we plot polyester composites. For large architectural reproductions or cheap souvenir figurines where high weight is an asset, this is the cost-effective choice. Moving to the middle right quadrant, we plot foreign industrial polyurethane. It offers moderate detail, but requires high formulation effort from the caster to stabilize it for art applications. Finally, in the top right quadrant, we plot U.S. art-grade polyurethane. This material demands a high premium cost, but it guarantees maximum microscopic detail and generational longevity. The founders of the hobby demonstrated over 4 decades that only the materials in this top right quadrant provide the structural stability required for genuine fine art castings. If you are a fine art caster or sculptor looking to optimize your studio production, the chemical data points to a clear strategy. Paying the upfront premium for U.S. polyurethane is mandatory. It is the only reliable way to avoid unpredictable curing, excess shrinkage, and ruined production batches. For the high-end collector, assessing the long-term durability of a prospective purchase, the strategy shifts to physical observation. You must proactively identify non-standard materials. If a miniature feels excessively heavy or emits a strong, lingering chemical odor long after curing, you are likely holding a cheap, brittle polyester composite. You protect your physical and financial investment by refusing to buy into the generic label of resin. Instead, demand the history that guarantees your fine art collection will stand the test of time.